Hello and welcome to Aliathon's 100G OTN demonstration video. My name is Alan McDade and I'm responsible for sales and marketing here at Aliathon. In today's video, we've implemented our 100G transponder in the Virtex 7 HT device on this 7 series characterization card. The card is connected to an Anritsu MD1260A 100G tester. The purpose of today's video is to perform interoperability with that tester, and as a result we won't be looking at the client-side interfaces. To view those interfaces in our full 100G demo video, go to aliathon.com and click the YouTube button at the bottom of any of the pages. The diagram on your screen now shows the hardware setup for today's demonstration. The FPGA platform used for the demo is a Xilinx Virtex 7 characterization kit, the VC7222. This card has a 580 HT device on board, giving us access to a number of 10GB and 28GB capable transceivers, although for this demo we are only using the 10GB variants. Inside the FPGA, we have implemented our 100G transponder and muxponder reference design, which transports a 100GE client or 10x10GB clients in the OTU4 payload. As today's demo is focused on Interop with the Anritsu tester, we do not need to connect any client-side test equipment. Instead, we have implemented a client-side loopback within the FPGA. So on the line side, we have the Anritsu MD1260A tester, which is configured in OTU4 mode. The box has an electrical CFP breakout module installed, allowing us to test the OTL 4.10 interface and all the associated functionality in the FPGA. This module is connected to the Virtex 7 card via a set of Samtech bullseye cables. Finally, we have a user interface that allows us to monitor the errors, stats and defects at all layers of the design. The diagram on your screen now shows the architecture of our 100G OTN transponder. As explained previously, we are concentrating on Interop with the Anritsu tester and therefore won't be talking about the 100GE client-side interface. As a result, we perform Cowie layer loopback within the FPGA, passing data all the way from the OTU4 layer to the 100GE interface and back again. On the Ethernet side, we have our Cowie interface. After bit demuxing, the individual lanes are 66B deframed, deskewed and reordered to produce an interface that is 10 aligned, contiguous 66B code words wide. The associated PCS and MAC blocks provide code word unpacking, frame delineation and CRC checking. The 100G Ethernet to ODU4 block bit transparently maps the 66B code words into an ODU4 payload for transport by the OTU4 framer using the generic mapping procedure or GMP. The OTU4 core provides standard G709 framing, scrambling, detection of parity errors and also adds or drops the overhead. The framer connects to our standard GFEC encoder-decoder block, which delivers 6 dBs of gain while consuming 7% of the frame overhead. The core provides full stats, which are corrected or uncorrected bits, blocks and codes. While this demo uses a standard GFEC core, Aliathon can also provide an enhanced FEC core, which delivers 9.35 dBs of gain for the same 7% frame overhead. On the OTU4 side, the design implements an OTL 4.10 interface, which supports up to 1024 bits of skew. This incorporates 10 11.18 gig SerDes with individual lane framing, skew adjustment and reordering. Finally, we have a soft microprocessor based subsystem which allows us to control and monitor the design via our Windows GUI. Moving on to our 100 gig muxponder. Again, we are concentrating on Interop with the Anritsu tester and therefore we'll be talking about the 10 gig client-side interfaces. Similar to the transponder just discussed, we perform loopback at the client side within the FPGA, passing data all the way from the OTU4 layer to the 10x10G mapper interface and back again. The 10G client mapper supports all the popular client types such as 10GigE, OC192 STM64, OTU2 and Fibre Channel. The 10 ODU2s from the client mapper connect to Aliathon's ODU2 to ODU4 mapping core, which in turn forms a single ODU4 and passes this to the OTU4 framer. The ODU4 mapper core uses the standard GMP mapping technique of multiple 1.25 gig time slots and multiplexes those into the ODU4 payload. The OTU4 framer core provides standard OTU4 framing, scrambling, detection of parity errors, and also adds or drops the overhead. The framer connects to a standard GFEC encoder-decoder block which delivers 6 dBs of gain while consuming 7% of the frame overhead. The core provides full stats, which are the corrected or uncorrected bits, blocks and codes. While this demo uses a standard GFEC core, Aliathon can also provide an enhanced FEC core, which delivers 9.35 dBs of gain for the same 7% frame overhead. On the OTU4 side, the design implements an OTL 4.10 interface, which supports up to 1024 bits of skew. This incorporates 10 by 11.18 gig SerDes with individual lane framing, skew adjustment and reordering. Finally, we have a microprocessor-based subsystem which allows us to control and monitor the design via our Windows GUI. Okay, so let's move on now with our demonstration. We'll start by looking at the Anritsu to Aliathon direction. So here we have the Anritsu tester open, and next to that we have the Aliathon GUI, looking at the design's errors, stats and defects. So we have the OTL tab open here, and if we begin to look at the OTL layer in the Anritsu side, we can inject some loss of frame alarms. We can do that on a lane by lane basis. So we can select lane 2, lane 8, lane 6 for example. OK those. And then when I click this button, we should see those lanes go down on the Aliathon side. OK, so there we see lane 2, lane 6 and lane 8. If we now move down to the OTN layer, and again look at the errors and alarms on the Anritsu side, we can inject a LOF and see that reflected. We can inject an error, an SMBEI, and again see that reflected. We can then move down to the ODU4 layer. And we can inject an AIS alarm. we can inject an ODU4 layer error, so BEI. And then finally, we can move down to the Ethernet layer. And we can inject high bear from the Anritsu side. And we should see the CRC error accumulator begin to build on the Aliathon side. Okay, so that concludes all of our tests in the Anritsu to Aliathon direction. If we flip that and look at the Aliathon to Anritsu direction, the GUI we have here is purely for monitoring the error stats and defects. It has limited test injection capability. But what we can do is we can switch to a terminal mode, and we can inject some PRBS on the OTL layer, and we can see that reflected in the Anritsu GUI. So we do this by switching to terminal mode, and then writing a value into the registers. So there we see lanes 4 and 5 showing errors. And now we see lanes 12 and 13 showing errors. Okay, so let's move on now with our demonstration. We've configured or reconfigured the Anritsu box in muxponder mode, and we've also reconfigured our FPGA design to also be in muxponder mode. So if we take a look at the GUIs now, they're very similar to before. The Anritsu now allows us to look at the ODU2s contained within the ODU4. And on the Aliathon side, we have replaced the COWI tab with an ODU2 tab. And you can see here that we're monitoring all 10 channels within the ODU4. So similar to the transponder presentation, we can inject alarms and errors at various levels of the design. So again, starting from the OTL layer, we can inject loss of frame. We'll do that for all lanes. And we can see all lanes going down. At the OTN layer, we can inject an SMAIE, and again watch that recorded. At the ODU4 layer, we can inject an AIS. And again, watch that recorded. And then now at the ODU2 layer, where we can see all 10 channels, we can begin to inject some specific errors and alarms. So if we start with alarms, we can choose an AIS at that level. And we see that on all lanes. We can look at BDI, again for all lanes. And then if we look at errors, we can look at BIP. And then finally, we can look at a BEI. That was BIP again, my apologies. Okay, and there's our BEI. That concludes the Muxponder demonstration. That's the end of the demonstration video today, and we hope you found it useful. To view Aliathon's other products and services, go to www.aliathon.com. To contact us and discuss your requirements, go to aliathon.com and click the Contact Us tab at the top of the page. Thanks for watching.